Well, this video series is about math skills that you need, and this is our 10th video. We're going to be looking at how to approximate areas using the trapezoidal rule.
This is Mr. Mac. He can explain things really well and is a lot of fun to watch. You can subscribe to Mr. Mac's physics channel. You will find mathematics problems, science demonstrations, astronomy and space pics, physics calculations and simple explanations of advanced concepts.
Here we can see a beautiful scenery around Berry in New South Wales. And here we can see also a field that is very irregular shape and has a dam in the middle of it. So the problem arises, how do we approximate the area of that? Because it's not a simple shape that we can just simply use a formula. And you can see this would be the boundary if we drew it on the picture. What we're learning to do is to approximate areas of various shapes using the trapezoidal rule. We'll be able to use the trapezoidal rule with several applications to approximate the area of irregular shapes. So using a trapezium, we can actually use that to approximate an irregular shape. Let's look at this irregular field from the picture on the first slide. We can redraw the plan without perspective. So I'll take away the photo, use the shape and redraw it looking down from the top as a plan. And you can see here that two of the corners are at right angles. And we can fill in a trapezium to approximate the area instead of using that curved side, which is very difficult to measure. And this trapezium will give an answer that is close to the real area of the field. So we'll use one application of the trapezoidal rule and see what we get. Here's the trapezium. Remember, a trapezium has two parallel sides that are opposite, and the other two are not parallel. So the area of a trapezium, we may remember, is h onto brackets a plus b, where a and b are the parallel sides. And this particular trapezium is quite squashed, so a and b are quite short, and the h, which stands for perpendicular height, in this case goes along the bottom of that diagram. And we can measure those in the real world. A, 36 metres, B, 50 metres, and H, the length of that field, we're calling it H, 92 metres. And we substitute. So 92 over 2 times brackets 36 plus 50, do that on the calculator, and we get 3,910 metres squared, which is good, except we've missed a bit. I wonder if we can do better. So let's try using the trapezoidal rule twice. So here's the plan again, and you can see how much area we've wasted and not counted by looking at that curved area and the trapezium underneath, and obviously we've missed out quite a bit. So we can measure the sides, but let's make one more measurement of 65 metres in the middle to make two trapezia. By the way, trapezia is the plural of trapezium, coming from the Latin and originally from the Greek, where trapeza means table. So here's the line through the middle, and we can measure it as 65 metres. Now you'll notice that this makes two trapezia, one on the left dark green and one on the right light green. And you'll notice that I've labelled the one on the left with A1 and B1, and that 65 metres works for not only B1 but also A2. It's the same measurement. So A2 and B2 for the right-hand trapezium. Remember that they are parallel and opposite each other. So the area of a trapezium is h onto brackets A1 plus B1 for the first trapezium. Substituting, now you'll notice that the height this time is half 92. Half 92 is 46. So both trapezia have a height of 46. So we put that into the formula. It's 46 on 2 times brackets 36 plus 65, which gives 2,323 metres squared. Now let's look at the right-hand side, the light green trapezium, and remember again, h is 46 metres. So we substitute that in, 46 metres onto times brackets 65 plus 50. Calculate that and we get 2,645 metres squared. And to find the total area, simply add those two together to get 4,968 metres squared. And you can see that that's a much better approximation to our field and it's got far less white space above the two trapezia. But I wonder if we can make a better approximation. Well, let's try 4 applications instead of 2 applications of the trapezoidal rule. So here's our field. We know that the distance along the bottom there, h, is 92 metres. And we divide it into 4 trapezia. We're having 4 applications of the trapezoidal rule. And you can see what happens. We've now got 4 trapezia that we need to find the areas of. And here are the measurements. Now, this time we've got 92 metres divided by 4 to get 23 for each of the little heights, remembering that height in this case goes horizontally. And each of the trapeziums has A and B, and we're just giving them subscripts 1, 2, 3, and 4. So A1 is 36. We knew that from our first measurement. A2 we measure as 55 metres. A3 is 65 metres. A4 is 61 metres. And the last measurement, B4, is 50 metres. And you'll notice underneath I've just put A2 is the same as B1, 55. A3 is the same as B2, 65. And A4 is the same as B3, 61 metres. So we simply find the area of that first trapezium, the dark green one on the left, and this time it's 23 on 2 times brackets 36 plus 55, which is 1,046.5 metres squared. We'll find the area of the second one, the light green. It's 23 on 2 times 55 plus 65 in brackets, which is 1,380 metres squared. And we'll find the area of the third trapezium, again 23 on 2 times 65 plus 61 in brackets, which gives 1,449 metres squared. And the last trapezium, 23 on 2 times 61 plus 50 in brackets, and that gives us 1,276.5 metres squared. And of course we add them together. The total area is simply the sum of those 4 trapezia. And here it is. The answer is 5,152 metres squared. That is a far better approach to what we've found before. Now let's have a look at that same field, and this time we'll focus on the dam. This is an aerial view taken by Google Maps and of that dam, that's the very same dam. And so let's take some measurements. We can find that the length of the dam is 39 metres, and we can take 3 measurements across the dam at different points, and we can see it's quite irregular. So 15 metres, 13 metres, and 20 metres respectively. And we can then approximate that by 2 trapezia. So there's the length, and so since we're having only 2 trapezia, the height that we'll use is 39 divided by 2, which is 19.5 metres. And there I've put labels on the other measurements. So A1 is 15 metres. B1 for the first trapezium is the same as A2 for the second trapezium, which is 13 metres. And the last measurement, B2, is 20 metres. So let's do the calculation. We can use those outer 2 measurements as the ends of the trapezium. So the area of the first trapezium on the left, the light blue, we know the formula is h on 2 brackets A1 plus B1. In this case, it's 19.5 on 2 times brackets 15 plus 13. which turns out to be 273 metres squared. And then we find the area of the second trapezium, the dark blue one, 19.5 on 2 times brackets 13 plus 20, which is 321.75 metres squared. And of course, to find the total area of the dam, we then add those two numbers together to give us 594.75 metres squared. Now remember, this is an approximation, so having that many significant figures is probably not useful. So what we'll do is round it to 2 significant figures and say that the area of that dam is 590 metres squared. And if we needed to calculate the area of the field around the dam, how much grass we have to mow, then we could subtract that number from the calculation we previously found of the total field. As you can see, the more times that we apply the trapezoidal rule, the closer we get to the actual area of that irregular shape. In our next video, we'll be looking at volumes, and particularly of pyramids and cones. I'm Mr. Mac. Thanks for watching.